Hi everybody, this is Mrs. Lehman from Math with Mrs. Lehman, and I am here today with one of my classes. If you would all say hello, please.
Hello.
This is very exciting. It's our first class participation YouTube video of the 2019-2020 school year, so yay. Anyway, so we're starting out today with a bell ringer. Yesterday my classes were super impressive. They were writing algebraic equations, so that was awesome. But today we're going to focus on proportions, and then we're going to focus on finding unit price. Okay? So anyway, let's start with this. So we're looking for a connection. In 6th grade, what we do, we're not doing the cross multiplication method. That's something you'll learn later. All right? Right now, it's all about ratios and scaling those ratios up and scaling them down. Okay? So what we want to do is find the relationship between here to here using multiplication or division so that we can, in this case, scale it up. Okay? So this is not compatible. 12 does not, multiply to give us 16, right? So we need to simplify. One of my coworkers, Mr. Mattingly, has a great quote. Does someone want to read that nice and loud with lots of pep? Go ahead, Araya.
If you can divide or multiply...
You gotta say can't. Emphasize that.
Wait,
Take 2. You said if you can.
Can divide or multiply. You must simplify.
All right. So again, if you can't...
If you can't divide or multiply, you must simplify.
No one's going to want to participate in my videos. Thank you. So if you get to a situation like this and these numbers aren't really compatible, we need to simplify them, okay? So we're going to simplify 12/18, right? They're both divisible by 2, by 4, and by 6, okay? My recommendation is try to go with the greatest common factor. If you divided by 2, for example, you would have gotten 6/9, and then still 6 does not multiply to give you 16, right? So you would have to go lower. So your options would be to divide it by 6, right? 12 divided by 6 is 2, right? 18 divided by 6 is 3. All right, if you divided it each by 3, 12 divided by 3 is 4, and 18 divided by 3 is 6. Those would also be compatible. So you're not wrong if you picked one of those. What you have to do, though, is find the connection from that number on the left here to 16. So 2 times what gives us 16? 8, very good. If you do it to the top, you have to do it to the bottom. 3 times 8 is 24, very good. All right, again, we're looking for the connection from our completed ratio, 6/10, to find our missing piece, right? What out of 15? So, can we multiply 10 by anything to get 15 as far as whole numbers? Bless you. No. So we're going to simplify. If you can't divide or multiply, you must simplify. So let's start by splitting it. Well, actually, it's going in lowest terms. The value of this is 3/5. So what do I multiply 5 by to get 15, Oz?
3.
Times 3. Very good. 3 times 3 is what? 9. Nice job. So 9 out of 15. All right, let's look at this next one. 20 to 28. Let's simplify that because 28 does not divide by anything to give us 21. So what is a common factor? What is a number that goes into both 20 and 28? Amari?
4.
4, very good. 20 divided by 4 is what?
5.
Everyone? 5. And 28 divided by 4 is? 7, very good. 7 times what gives us 21, Dahlia? 3, very good. So 5 times 3 is? 15, nice job. So I was talking to my classes earlier, and I'll explain this to you as well. You want to make sure your answer makes sense, right? We know that 20 to 28 is scaling down to something out of 21, right? The numbers are getting smaller. So if this were a multiple choice thing and this was some sort of word problem where you had to set this up to figure it out, you would not want to pick an answer that was bigger than 20, right? you would also want to pay attention to, like, this 20 is less than 28, right? 15 is less than 21. If you got some number that was bigger than 21, you know that wouldn't make sense. All right, you can also use some sort of estimation and judgment as far as 20 is a good part of 28, right? It's a decent portion of 28. 15 is a decent portion of 21. If you got an answer of 3, let's say by accident you put a 3 there, 3 is not a very large part of 21. So that's where common sense kind of will help you. It'll be your safety net. Yes?
When you're doing it, I don't get it. I don't get what we're doing.
You don't get what we're doing. Okay. Do you know how to simplify the fractions? Okay. So what we're doing is we're simplifying it down to the value of the ratio, which we've practiced, and you did that a lot in 5th grade, right? And then what we're doing is we're scaling it up. So we're used to scaling it up with ratio tables or double number lines. We're kind of doing the same thing, except we're not drawing the table. All right, we're saying how many times do I have to write 2/3 and scale it up to get it up to 16? In this case, right? I'm going to pause the video for a quick sec. All right, so we had some really excellent questions. I really am happy that my students are asking those things. It's just I didn't want to put all of that in the video due to time's sake. So great questions. If you have more questions, please ask. Okay, so let's move on. Today what we're going to do is find the unit price of some products, okay? We talked about unit rate and how una means one, right? A unicorn, unicycle, if we unite, we come together as one. So what we're doing is finding the price of one thing, okay? So I'm going to give you an example. So on the paper that the students have, they're going to write down EX, for example, and I'm going to pretend that I'm going to Walmart and I am, or some, did you? Did you buy donuts? Because that's what we're buying now. All right, I'm going to buy a 6-pack of donuts for $3.60. All right, so $3.60 for 6 donuts. This is going to make us hungry. All right, so to find the unit price, we want to figure out how much is 1 donut, okay? So find the unit price, which means cost of 1 donut. Maybe I'm going to put parentheses here instead of that because I don't want it to look like a subtraction thing. Cost of 1 donut. All right, so that's our goal. Now, we're going to use an operation to do this. I'm going to draw out what you guys probably, you would have used a tape diagram last year, but I'm just going to visually show 6 donuts. All right, so I've got 6 donuts here. How would I find the price of 1 donut? I know all of them are $3.60. How would I find just 1 donut? Isabella?
$3.60 divided by 6.
Perfect, nice job. We're going to use division. I hope you wore your glasses because it helps with division. All right, so we are moving on. We're going to take $3.60. And we're going to get fancy with this now that we're in 6th grade. We're going to put over 6 donuts. We're going to divide just like Isabella told us to. So this is where I give you my calculator speech. Today's exciting. We're doing so much today. All right, so you guys have calculators. Before you touch them, I want to tell you a little story about my refrigerator. Just kidding. I want to compare the calculators to my refrigerator. So my refrigerator has one job and one job only. Who can tell me what the only job my refrigerator has? Kaylee.
To keep your food cold.
Perfect. To keep things cold. A refrigerator refrigerates, right? A calculator does what? Calculates. Now, does my refrigerator do my grocery shopping for me? No. Does your refrigerator pick the stuff out of the recipe that you need? No. Does it go to your cupboards and then mix it all up for you? No. Does it bake it in the oven for you? No. When you're done getting the stuff out of the fridge, does it put it on plates for you and give you silverware and stuff? No. You wish, right? So some kids are mistaken and they think the calculator is the answer to the universe's most difficult questions, right? They think, I can solve anything in math, I now have a calculator. Well, if I put garbage into my refrigerator, what am I going to get? Cold garbage, okay? So keep that in mind when you're using your calculator. If you don't carefully read a problem, if you don't plan out what steps you're going to take to solve it, if you don't show your work and write down what you're going to type into that calculator, and if you don't then label your answers and, you know, do what you need to on that end, the calculator will not do it for you. It will only calculate whatever you put into it. All right, so that's my story of the calculator in my refrigerator. The other rule I have for 6th graders for calculators is if you plan on typing something into your calculator, you are not to type a thing in until you have it written on your paper. So for example, we just wrote $3.60 over 6 donuts. We have shown the work that we need to, okay? Then you can type it in. So go ahead and type in 3.60 divided by 6. Now don't push equals yet because on your screen it will show you what you typed in. And I know, for example, my computer at home does not like, you gotta turn it on, all right? So go to the on button, clear it out, there you go. So my computer keyboard at home does not want to type a 5. I have to really pay attention when I'm typing numbers that the 5 actually shows up because it's pretty questionable, all right? So what I want you to do is before you ever push equals, make sure your calculator says what you mean it to, okay? Because sometimes kids accidentally type in the wrong numbers. So it should look like on your calculator, oops, it's not going to have the dollar sign. It's going to say 3.60/6, right? That's the way it's showing division. So go ahead and push equals. 0 and 6/10, right? Well, you got to clear it out and try again. All right, so 60 cents. Are you with me? When you type that in, you're going to get 6/10, right? Now notice that answer is not labeled for you, and that's not how we write money, right? How many spaces past the decimal point do we need for money? Kelly? 2, right? Because it's 100 cents, right, to make $1. So we need a 0 added to the end. We can only add zeros after a number, after a decimal point, okay? We don't want to put it ahead. So how many cents is that? 60 cents. I'm going to write it in terms of dollars, though. So $0.60 per, which means for every what? Donut. All right? Any questions on how to set those up? We're putting the money on top because when we're done, we want the price for one something.
Okay, I get it.
Whether it's 1 ounce, 1 pound, 1 can of soda, 1 ounce of crackers, 1 juice box, 1 dozen eggs, or whatever we're talking about, okay? So let's move on to your paper, which looks like this, and this is a terrible, it came up terrible on here, so I did my best, but I'm going to have you guys look at your papers. The first thing says that a box of crackers costs $3.49, and that's for 12 ounces. All right, we want to find the price per ounce. So on your sheet of paper, label this number 1, right under your other example. And we're going to set the same thing up. So what was the cost of the box of crackers, somebody? Nathan, nice and loud.
$3.49.
Thank you. $3.49 over, meaning divided by, how many ounces in that box? Maggie, nice and loud.
12.
12, very good. And when you write ounces, just be mindful that you write that nice and small so it doesn't look like 120Z. All right. All right, let's do the math now. Once you have it written down, you can now type it in. And pause this till we're done. So everyone got 0.2908, but you know, we don't need to worry about that because we're just talking about cents here. So you want to go to the second spot over. We're going to round to the nearest whole cent, which is the 9, right? And what you do is you look behind it. And you have to decide, is that number behind it strong enough to bump that up to 30 cents? Or are we going to let it go and keep it at 29 cents? All right, that's what we're doing. So 5 or above, we give that 9 a shove up to 10, which changes it to 30 cents. Or 4 or below, we're going to let it go and just keep it at 29 cents. Okay? So what am I going to do, Oz? Round up or down?
Down.
Down. We're going to drop off the point, or the, not the point, but the 0.8. So that is going to end up being approximately $0.29 for every, or per, what? Isabella? Per ounce. Beautiful. All right, and then draw a box around your answer. All right, I'm going to let you guys do your next one on your own. We'll come back with the answer in a moment. What we're doing is, for question 2, we have another, oh, we still have another box of crackers. Whoops, we're not on question 2. We're still on question 1. Let's find out the other box of crackers. How much is the other box of crackers? $3.99. And how many? 16 ounces. Bigger box, but is it, it's more expensive for the whole box, but is it cheaper per ounce? Let's find out. All right, so we have, this is our calculation here. We're going to underline the 4, draw a little arrow to the 9. So we're looking, is 9 strong enough to bump that up to 25 cents, or are we going to keep it at 24 cents? What do you think, Sanaya?
Oh, you're going to bump it up.
Bump it up, yeah. So that will round to $0.25 per what? Ounce. Nice job. So, which box of crackers has the better unit price? The 12-ounce box or the 16-ounce box?
16.
The 16-ounce box. By how much? How much are you saving per ounce by buying the 16-ounce box, Dahlia?
4 cents.
Very good. 4 cents per ounce cheaper. Okay? This is going to add up quickly when you're grocery shopping. Let's see if we can get another one done before the end of the period. All right. Let's go back here. We have some juice boxes, and we have an 8-pack. All the juice boxes are 12 ounces apiece, and that's $3.85. We also have a 10-pack, also 12-ounce boxes, so they're equal box size. It doesn't matter. That part is just kind of extra. And that's $4.89. So we got to figure out which is the better deal. All right, so let's go under or on the next thing here. So 8 for $3.85. So let me add a page. That didn't work. Let me try that again. Huh. Did I just delete a bunch? I think I deleted. Whoop. Undo. Redo. All right, add a page. There we go. So what was the price for the 8-pack? $3.85. So this is question number 2. $3.85 for every 8 boxes. Right, and then you're going to do the division once you have that written down. Who can give me the first 3 digits past the decimal place? Go ahead, Araya.
0.320.
320, is that what you guys got? That's not what I got. Check it again. 3.85 divided by 8. You gotta make, that's why it's important to check your screen.
I got 0.481.
Yep. I got 0.481. Make sure you're typing in that top number first. What? Boxes of juice. Yep, juice boxes. All right, so 481, what will that round to? How many cents? Amari. Very good. So we're going to look to see if we bump that up to 49 or keep it at 48. Well, there's only a 1 there, so we're going to round it down to 48 cents. Good job. So $0.48 per what? Per box. All right, let's figure out the other one. I'm going to pause this, and you can go ahead and figure out the next one. Hold on. Sarah, go ahead. All right, you typed a decimal place in the wrong spot, so if you could just double check that you typed in 4.89, because you should have gotten this. You had the numbers right, but the decimal was in the wrong spot, which tells me you just typed in your decimal in the wrong place. Okay. All right. What do I want to do here? I'm going to look at the 9, 5 or above. I'm going to give it a shove. 4 or below, let it go. Am I keeping it at 48 cents, or am I rounding it up to 49 cents? What do you think, Nathan?
You're rounding it up to 49 cents.
Very good. So $0.49 for every or per what? Box. Nice job. So which one is cheaper, the 10-pack or the 8-pack per box?
The 8-pack.
The 8-pack is cheaper per box. Nice job. All right, I'm going to end this video because the bell's going to ring. I want to thank you guys for watching our first official-ish video of 2019-2020. And thank you to this class. If everyone could say goodbye.
Goodbye.